Hello learners, welcome to this lesson. I want to believe that you are doing well from wherever you are attending this lesson from. So today we are going to do a chapter on weather, actually geography, and we are going to do a chapter on weather. And so I would invite you to subscribe to this lesson, like and even share. Also give us your opinion in the comment section. So by definition, weather is the daily atmospheric condition of a place over a short period of time, and usually 48 hours. That is a period of 2 days. That is a period of 2 days. And again, so the keywords here are it is the condition, it is an atmospheric condition, the daily atmospheric condition of a place. And also you need to state the period of time, because we also have a comparison between weather and climate. So for weather, it is for a short period of time, and it is estimated to be a period of 2 days or roughly 48 hours. Now, you can also be told to differentiate between weather and climate. So the key differences, or the key difference is, weather is a condition, a daily condition, atmospheric condition of a place, but climate is the average weather condition of a given place for a long period of time. So let's now move to the elements of weather, and we have the following elements of weather. Number one is temperature, we have humidity, we have precipitation, air pressure, wind, sunshine, and cloud cover. So for today, we are going to focus on temperature, so that in our next lesson, we'll be doing precipitation. So about temperature is the degree of the sensible heat within the atmosphere. So, or some other people, rather some other books say that it is the degree of hotness or coldness of a place. So this one, hotness or coldness of a place. But if you say the degree of sensible heat within the atmosphere, still you'll be able to get that concept very well. Now, it is measured by an instrument known or called a thermometer, and which is given in degrees Celsius, Now, we have lines that are drawn on a map joining places with the same temperature. These lines are called isotherms. So we are going to now we'll be looking at some of the factors that influence the amount of solar radiation reaching the Earth's surface. Some of the factors that influence the amount of the solar radiation reaching the Earth's surface. And number one is the intensity of the sun's radiation in the space, and the Earth's average distance from the sun. So the distance between the Earth and that of the sun will actually influence the amount of sunshine that is being given, or rather radiated, on the Earth's surface, or the intensity of the sun's radiation. It may vary depending on some other factors like cloud cover and so on. Number two, transparency of the atmosphere. So that is transmission, absorption, scattering, and reflection of the sun's rays by particles found in the atmosphere. So for point number one, we have just said it is the Earth's average distance, and another one is here about the intensity. Point number two is about the transparency of the atmosphere. And now point number three, the position of the Earth on its orbit, which produces different seasons. So Of course, because of the seasons, it will cause insolation to vary with the time of the day and the period of the year. Of course, if you look at the solar system, and then you'll be able to have under revolution of the earth, that is where we meet the seasons. That is where we meet the seasons. Another thing is the inclination, or rather the angle of the earth's surface on which the sun's rays fall. It's also another factor that is going to influence the amount of solar radiation reaching the earth's surface. So we have this, and another one is the area and the nature of the surface on which the rays are falling. So you can just look on those 5 factors. The other one is another point. We are going now to look at some of the processes through which the earth is heated. And we have one is radiation, another one is conduction, and the third one is convection. So let's start with radiation, which is the transfer of heat. Radiation is the transfer of heat via electromagnetic waves. So actually the main point here is the transfer of heat via electromagnetic waves. Now, radiation travels in waves that are very small and are transmitted from one place to another without the help of a medium, or it travels in a vacuum. So the earth emits heat by long wave radiation called terrestrial radiation. So terrestrial radiation, these are long wave radiation. So now let's look at some of the difference between solar radiation and terrestrial radiation. The difference between solar radiation and terrestrial radiation. And for one, solar radiation is short wave. And terrestrial radiation is long wave. I think that is giving us a comparison. 2, solar radiation is partially visible for solar radiation as sunlight. It is visible as sunlight, while terrestrial radiation is invisible. We are not able to see this kind of radiation, the terrestrial radiation. And that is why at night you'll be able to feel some of the heat radiated from the earth, actually from the walls. It is the terrestrial radiation, you're not able to see it. But with solar radiation, you'll be able to see it as sunlight. Number 3, solar radiation takes place only daytime, while terrestrial radiation occurs all the time. So a point of comparison in this number 3 is this is during daytime and this one occurs all the time. So those are areas of comparison between the two aspects. Let's now move to conduction. Conduction is the transfer of heat through matter without moving it. Now it is the transfer of heat energy through motion. From one molecule to another. Air in the atmosphere is heated by direct contact with the Earth's surface. We are now moving to the third process, which is convection. And about convection, it is the transfer of heat through mass movement of a substance. I think that is where we have the main point here is through heat through mass movement of a substance. Now the substance in this case could be air, or it could be air or water. It takes place when air is heated by earth, becomes less dense, and now rises to higher levels, transferring heat with it. And actually this is what give us, this is what happens during the formation of convectional rainfall. Convectional rainfall. So I think those three processes are very key to heat transfer on the earth. Let's now look at some of the factors influencing temperature on the earth surface. Some of the factors influencing temperature on the earth surface. Okay, so number one is latitude. Number one is latitude. And we are going to look at how this factor influences temperature on the earth surface. Of course, when you talk about latitude, you understand that we have different latitudes on the major latitudes. So we have, if this is the globe, then we have this is the major latitude, which is the equator, 0 degrees. That is 0 degrees. Then we have this latitude, we call it Tropic of Cancer. It is always 23 and a half degrees north. And there's another one here, which is 23 and a half degrees south. Yeah, so those are some of the major latitudes. We have also we have the Arctic, and we have another one, Antarctic. Okay, let's now these are now the latitudes. So for someone who was maybe asking what latitudes could be, then these are the latitudes. Now, temperature decreases with increasing latitudes. Temperature decreases with increasing latitude, and vice versa is true, whereby you say a decrease in latitude increases leads to an increase in temperature. A decrease in latitude leads to an increase in temperature, because if you look at the region that surrounds the equator, it is actually, the solar insolation is actually so intense, and so there is high temperature around that place, as compared to the polar regions where we have the Tropic of Cancer and Tropic of Capricorn, and the Arctic and the Antarctic. And now we say highest temperatures are generally at the equator and the lowest at the poles. The lowest at the poles. As you can see in this diagram, whereby this is actually, this is the sun rays, which is hitting the equator at 90 degrees. So it is just straight. And the sun rays will actually be able to travel long distance to the poles, long distance to the poles. And so by the time it's getting to the poles, its intensity is going to be lowered, or rather to decrease. And that is why we say the latitudes that are far away, actually the ones that are, okay, if you compare the latitudes which are towards the poles and the ones to the one that is at the center, that is actually the equator, then there will be some variance in terms of temperature. Okay, so there is a question which is asking, give reason why the intensity of the insolation is higher at M, that is the equator, than at N, that is the poles, both sides poles. So for one, there is a higher concentration of heating at M than at N, because surface area at M is smaller than that at N. That is very correct. The surface area at N is smaller. At M is, the surface area at M is smaller than that at N. And that is why there is huge concentration of sunlight at the equator. Another reason the angle of the sun's rays at M, that is the equator, is higher than at N, hence variation in intensity. So if you look at the angle here, I said it is 90 degrees compared to that one which is at the poles, that is N. So that is what makes it. So the concentration here is going to be much higher than the poles. In our part 1, in the reason number 1, we said that there is higher concentration. So this is the point. The point is here than at N, and it's also giving us a reason, which is this one. Okay, number 3, at N actually the poles, sun rays travel over long distance than at M. Sun rays travel over long distance than at M, thus losing the heat resulting to low intensity. So actually that is what I said, that when you look at the distance from the sun, assuming that the sun is somewhere here. So look at this distance. This is going to be a direct distance as compared to this. So this one means there will be high concentration of sunshine at the equator compared to the poles, because the rays here has to travel longer distance to deliver that particular sunshine, and by the time it is getting there, it is going to be of low intensity. So those are the 3 major reasons why the concentration of solar insolation is higher at the equator than the poles. Okay, now let's move to the second point. Which is, let me just make this one visible. Let me make it visible. Yeah, so we are now going to look at the second factor, that is altitude, or height above the sea level. So altitude is actually the height above the sea level, and we are going actually to see how it's going to influence temperature on the Earth's surface. So temperature decreases with an increase in altitude. This is actually a point that you should master, that temperature will decrease depending on the altitude. So temperature decreases with an increase in altitude. Now this is also known as normal lapse rate. And now what happens on low altitude and also on high altitudes? So of course the temperature will vary, but we are going to see how is it going to change. So low altitude areas have high temperatures. Low altitude areas, of course, when you talk about low altitude areas, these are lowlands. And so lowlands, there is high temperatures because air is heated from below by the Earth's surface, that is the terrestrial radiation. So there is higher concentration of terrestrial radiation in the lowlands than highlands. That is probably what makes it to have higher temperature concentration. So the main point here is the reason why it is very high. Number 3, high altitude areas have low temperatures. And we are saying that because of, when we talk about high altitude areas, we are referring to highlands. And then this statement, we are supposed to give reason why there is high altitude, why there is low temperature in high altitude areas. It is because of the particles. Like gases, dust, smoke, and water vapor, which store heat and lose heat rapidly to the outer space. So this is actually the reason why the temperature is very low. Because In highlands, we have a raised terrain, that is the steep slope, that is the hills, mountains, plateaus, and things like that, which have got effect, which have got effect on temperature of the surrounding. Now, I think that is well explained. We want to move to the third factor, that is length of the day. Length of the day. And now we say the longer the period of solar insolation, the greater the amount of radiation received at a given place on the Earth's surface, and the higher the temperature, of course. Longer period of insolation, of course, is going to influence higher temperature because there is too much concentration that occurs during that particular period. So if there's a point here to note, a point that you should note here is that the longer the period of insolation, that is, in any given day, the period of insolation, maybe it can be too long, maybe from 8 we have started receiving the sunshine, the rays. It will go up to later in the afternoon without being interrupted by things like rainfall and others. So in that particular day, we are going to have a longer period of solar radiation or insolation. So what is the effect of this? It's going to influence the amount of the quantity that is going to be received for that particular duration. So for the longer period of solar insolation, we are going to have a greater amount or a greater quantity of radiation received at a given place, and actually it's going to increase, or rather it's going to raise the temperature of the day. It will raise the temperature of the day. So we have this point, and another one we have about this one. Those are things that you should actually note when you are describing, or rather explaining, the length of the day as a factor influencing temperature. Yeah, so let's move to the fourth point. The fourth point, which is about the fourth point is on, let me see, winds. The fourth point is on winds, and so let me just zoom this so that you'll be able to see it well. So we have winds. So if you look at winds, that one, so we are going to see how winds how winds influence the temperature on the Earth's surface. So various types of winds affect temperature. And you should know that when you talk about winds, then you should actually understand that winds are a medium of transfer of air from one place, or heat from one place to another. So this point is very, very important to know, that from one place to another. So that is what winds do. Wind carrying warm air brings a warming effect to a given place. Winds that are carrying warm air bring a warming effect to a certain place. On the contrary, it is actually true, because if you see, winds that are carrying cold air bring a cooling effect to that particular place. So that is the effect of wind. So on the other thing, we also need to underline this part. Take note of this part, because it is very important. Okay, on another factor, ocean currents. So we say ocean currents may be warm or cold. So we have warm ocean currents, we have cold ocean currents. So we have this. cold or warm. When the winds blow over these currents, these ocean currents, they get their warmth or cold and affect the temperatures of the coastal areas. So, for example, if I may just uh, uh, delve into warm ocean currents. So, warm ocean currents flowing or rather blowing on the ocean or the onshore winds, then it's going to bring a warming effect on the adjacent coastal land, and that is going to raise the temperature, which eventually will be able to give us rainfall, because it is also carrying some moistures. It's also carrying some moistures which will be dropped to the nearby land. Okay, so for example, so that is the effect of warm ocean currents. There is also the effect of cold ocean currents on the adjacent land, to the adjacent land. So of course it's going to bring a cooling effect, and that is why coastal regions or other coastal areas that are near okay, the lands that are near the ocean current, or I mean the ocean, whose ocean current whose whereby the ocean currents are the cold, the cold, then it means they are going to develop to a desert with the time. They are going to develop to desert because of that, the cooling effect. Because of that cooling effect. Let's now look at, for example, warm North Atlantic drift raises the winter temperature of the Northwest Europe. That's just an example. We also have some of the examples that are actually in Africa. We have the Namib Desert in Namibia. We have Kalahari, which is in the south coast of South Africa, and some others. Let's now look at the aspect. An aspect in this case is the direction in which a slope faces in relation to the incoming solar radiation. It is actually the alignment of the slope of the mountain in regard, or rather with respect to the incoming solar radiation. Now we say the south-facing slopes in the northern hemisphere. The south-facing, we are actually looking at this part. You should be able to note the main point. Note the main point, because we are looking at facts. And now we have just said that aspect is the direction in which, the slope, which are slope faces in relation to the incoming solar radiation. Now the south-facing slopes in northern hemisphere face the sun, thus receive more sunshine. They receive more sunshine, which raises the temperature of that particular environment than the north-facing slopes, in the southern hemisphere. In the northern hemisphere. Let's now move to cloud cover. Cloud cover. Let me just make it. Yeah, this is the point. So cloud cover. So for cloud cover, the presence of clouds in the sky, prevents the amount of solar radiation, to the Earth's surface. It also prevents the ground radiation leaving the Earth's surface. So we are talking about the concentration of the clouds and the presence of clouds in the sky. They have some effect when it comes to the solar radiation, because they are going to block the solar radiation from being received from being delivered on the Earth's surface. And now we are saying that the presence of this, presence of, yeah, that is the point. The presence of clouds in the sky prevents the amount of solar radiation coming to the Earth's surface, coming to the Earth's surface, coming to the Earth's surface, and also it prevents the ground radiation from leaving the Earth's surface. So this is actually the reason. Because of this, the places where clouds are less, it will experience high day temperature and a much lower night temperature, because a situation whereby the clouds are less in the sky, then that means there is a clear path for the sunshine to travel to the Earth's surface, and so that is going to raise the temperature of the day, and is going to be lower at night, or rather the night temperature is going to be reduced. In the equatorial areas, because of the abundance of cloud cover, the day temperature are not so high, the night temperature not so low. So that is actually all about cloud cover. Remember, we are actually looking into factors which influences the temperature. Our main focus is on temperature. How it's going to be. Okay, when we say that it's a high temperature or a low temperature, what actually some of the factors that has caused it. Let's now move to distance from the sea. Distance from the sea. And in this case, we say that areas near the sea or ocean experience what we call sea breezes. Sea breezes. So it will experience sea breeze during the day, which lower the temperature of the surrounding areas. It lowers the temperature of the surrounding areas. So we are actually talking about these are sea breeze, land breeze. These are local winds. These are local winds, and they are being caused by the temperature, variation of temperature, either during the day and night. So areas near the sun. So this is actually the point. Areas near the sun. I mean, areas nearer the sea. Sorry, areas nearer the sea or ocean will experience sea breeze during the day, and underline this during the day, because when it is night time, what another type of breeze occurs called land breeze. So you should be able to make that statement correctly by stating during the day. Now, at night, land breeze raises the temperature of areas surrounding the ocean. So at night, the ocean environment or water body is going to experience a high temperature. So that is is going to be very important. So this part. So formation of heavy convectional rainfall in areas nearer the sea also regulates temperatures of such areas. Regulate temperatures of such areas. When you talk about heavy convectional rainfall, then we are talking about that regulation of temperature and convectional currents. I think we just looked at the convectional currents, something that leads to the formation of the convectional rainfall. Yeah, that is actually the distance from the sea and its effect to the temperature. So let's now look at another thing. We want now to look at some of the measurement of temperature, how we can measure temperature. Let me just zoom it this one so that we'll be able to see clearly. Yeah. So this is the thing now. We are looking at the measurement of temperature. And when we want to measure temperature, or rather when we're measuring temperature, we are going to use a special instrument called a thermometer. So temperature of the atmosphere is measured using an instrument called thermometer. thermometer, which is something that is worth noting. So we have this temperature, I mean a thermometer. So we have various types of thermometers. We have the maximum, we have maximum thermometer, we have this one, maximum thermometer. We have also minimum thermometer, and we have the 6 thermometer, which is actually combined maximum and minimum thermometer. So those are actually the 3 main types of thermometers. Let's now look at the maximum thermometer before we come to the other types. Maximum thermometer. And now we are saying that this thermometer uses mercury. That is something that you can note down what it uses. It uses mercury. It uses mercury to record the highest temperature reached in a day. Okay, when the temperature rises, the mercury expands and pushes the metal index forward, as you can see in the diagram. Now, when the temperature falls, the mercury will contract. So there are 2 things here. We have mercury expands and mercury contracts. If it expands, it is going to give you a high temperature reading. Then if it contracts, then we are going to have a low temperature reading. The maximum temperature reached in the previous 24 hours is shown by the metal index that was in contact with the mercury last. So the diagram is here to make you understand. The diagram is there to make you understand. Let's now move to minimum thermometer. Yeah, so minimum thermometer, it records the lowest reached, the lowest temperature reached in a day using alcohol. So the liquid used here is alcohol. The liquid that is used here is alcohol. You remember in maximum thermometer, the liquid that is used is mercury. And now when the temperature falls, the alcohol contracts and its meniscus pulls the index towards the bulb. So you also need to take keen note of these 2 aspects. Also need to take keen note of the temperature falling, then what happens. So this statement will give you the point. When the temperature rises, the alcohol expands, leaving behind the index. Alcohol expands, leaving behind the index. The minimum temperature is in the previous 24 hours is obtained by reading the scale at the end of the index nearest to the meniscus. Now to reset the thermometer, raise the bulb of the thermometer gently. You'll be able to have reset that one. Yeah, so we can now look at the diagram. We can now have a look at the diagram and we'll be able to see. Now this is the diagram. This is actually the diagram of that particular. So okay, let me just, yeah, so you're able to see the diagram. So that is the diagram. As you can see, the main liquid is alcohol for minimum thermometer. For maximum thermometer, it is mercury. Yeah, so let's now move to 6 thermometer, which is a combination of minimum and the maximum and the minimum readings, or other thermometers. So 6 thermometer record the maximum and minimum temperatures reached over a period of time. For example, it can be 24 hours. 24 hours. So I'm going to illustrate using the diagram that is actually here. There's a diagram here because, yeah, so that you'll be able to see the both of the liquids that are being used in the 6 thermometer, because the 6 thermometer, it uses it is a combination of maximum and minimum thermometer. Maximum and minimum thermometer. That means it's going to use mercury and alcohol for that case. Now we are saying that When the temperature rises, alcohol in the left hand column expands. Alcohol in the left hand column expands, pushing the mercury below the downward and up, below the downwards and up the right hand column. So of course, as you can see in the diagram, we have alcohol and we have mercury. So this is actually alcohol. You can see the liquid that is inside here. The liquid that is inside here, that is the alcohol, and the liquid which is the darkest part, that one, that is the mercury. So that is M, and this is alcohol. That is alcohol. So when the temperature rises, alcohol in the left hand column, of course we are talking about this one, we're talking about that, it is going to expand, pushing the mercury below the downward and the up right hand column. So it's, of course, when it expands, then this one will be pushed. This material, this liquid here will be pushed. That is going to be pushed. And now the mercury in turn pushes the metal index in the right hand column. This one, the mercury here, is going to push this metal index. Is going to push, because remember there's been a push. There's been a push due to expansion of alcohol, which has made the mercury to also be pushed, and that is going to lead to a metal index being also pushed on the right hand column. And now this is going to give us, or rather we are going to have the maximum temperature reached in the last 24 hours shown by the end of the index. That is going to give us a reading of the maximum temperature by the end of the index, the metal index, which was pushed. That was last in contact with the mercury in the right hand column. So there is this one. And so the maximum temperature will be reached, and it will be on the end of the metal index in the right hand column. Metal index in the right hand column. Now when temperature falls, on the other hand, temperature falls, what will happen to the reading? What will happen? So when the temperature falls, alcohol, of course, is going to contract. Alcohol in the left column will contract, and of course it will pull the index along the tube. It will pull the index along the tube. And so the temperature when the temperature increases, alcohol expands. So the main point in this case is that, and it will contract, and of course it will pull. So probably this is giving us, that part is where we have the main about how the 6th thermometer is working. It is giving us how the 6th thermometer is working. Now when the temperature increases, the alcohol expands, leaving behind the index. The minimum temperature in the last 24 hours is shown. The minimum temperature within the last 24 hours is actually shown by the end of the metal index near the alcohol meniscus. That is why I said within this region, this point gives us the working, how the 6th thermometer works. Now the thermometer is reset using a magnet after reading have been recorded. So actually this is the diagram. And you'll be able to, you are supposed to understand how it works, so that you'll be able to even draw it and explain how it works. Now you can also be told to name some parts. Maybe you can be given a diagram, and so you are told to name some parts. So of course this shaded liquid is the mercury. The dotted one is alcohol. That is why I've abbreviated it as A, or with A. Yeah, so that is A. And now this is the mercury. This is the mercury. And the metal index is here. Another one is here. And so there are two terms that are widely used here: expansion and contraction. So you should know when alcohol expands, or whether alcohol, of course, alcohol is the liquid that is on the top. So when it expands, then what happens? You should be able to explain that. And when it contracts, you should also be able to explain what actually occurs after that. Okay, so let's now move to something else. Let's move to something else in that part. We want now to look at the temperature readings. Temperature readings. And now temperature readings. Now the reading of the maximum and minimum temperatures are used in the following calculation. So after we have got these results, then it is going to help us to do some of the calculations, and one of them being calculation of the diurnal temperature range. The diurnal temperature range, whereby we say, of course, anything to do with the range, it is actually the difference between the maximum and the minimum value. So daily temperature or diurnal temperature range is the difference between maximum and minimum temperatures recorded in a day, that is a period of 24 hours. So of course, if the maximum temperature was 28, let's say 28, that is actually the maximum temperature. It is 28. So we have maximum to be 28, and the minimum, which is maybe 17. And so the range will be 28. You get the difference, whereby you are going to use subtraction. So it will be 28 minus 17, and that will give you 11. Is it 11 or what? 28. So if you do your calculation very well, you'll be able to get that particular value. Of course, it's going to be 9. And so the other calculation which you can do with the values, will be mean diurnal temperature. This range is going to be 11. If you take 28 minus 17, it's going to be 11. So let's move to part B, mean diurnal temperature. So this is the average temperature reached in a day, and the main important thing is to know how it is being calculated. It is obtained by adding maximum and minimum daily temperatures, then dividing by sum of 2, because we are talking about the diurnal temperature, of course, the mean daily temperature. So we are going to take the sum of the maximum and minimum, of course, and then you divide by 2, because there are two values that are being involved. Number three, which is this one. Of course, we have tackled that, and we have tackled that one. So mean monthly temperature, which is going to be the average temperature of the month, is obtained by adding all the daily temperature. So this is where we are going to get the operation in the month. So we do adding, the addition, there is addition, and then dividing by the number of days in that particular month, because we are talking about the monthly, not annual. It is monthly. So we must be able to divide day 1, day 2, day 3 up to the last day. So of course, days in that particular month. So after adding all the temperature values, then we'll divide by the number of days in that month. That is number 3, mean monthly temperature. Let's move to mean annual temperature. Annual is being used to refer to year. So when we talk about the mean actually we get the sum of the total number divided by, or rather the sum of the numbers divided by the number of items. The number of items, that is how we calculate mean. Now when we talk about the mean annual temperature, then we mean the average temperature for the year, average temperature for a whole year. And remember, a year has 12 months. A year has 12 months. So it is obtained by, that is the most important thing here to note, obtained by adding all the monthly values, that is the temperature, and dividing by 12. That is the number of months in a year. Number of months in a year, which is 12. Yeah. So let's now move to, I think that is so simple. We are going to look at an example whereby we will be able to have a statistical table that will be asked to find these particular, to do these particular calculations. So part E, the annual range of temperature. Annual range of temperature. Annual range of temperature, we are going to get the difference between the highest and the lowest mean monthly temperature in that given year. Anywhere you meet range, then that means you're going to subtract between the maximum or the highest from, or rather, and the lowest. So you get the difference in between those two values. Then you'll be able to get that the range. Okay, so let's now move to